In section 6.4, we'll be dealing with combinations. So for this lesson, I will talk to you guys about a new formula, and also I need to talk about the difference between a combination and a permutation. All right, so let's get started here. Let's do a few warm-up problems first. For example, if I have six swimmers were in a race, how many different outcomes are possible if three swimmers are chosen for first, second, and third place? So since the order is important, because we'll have someone for the gold, silver, and bronze, order is important. This scenario would be a permutation because order is important. So I can just simply calculate 6, pick 3. So I have 6 swimmers, so there's my 6, and since I need to know the outcomes for first, second, and third, my R value will be 3. So 6 pick 3 will be, well, the 3 means you have 3 spaces, 1, 2, 3, and then N is your 6, so you go from 6 to 5 to 4, and then you get 120 ways. Or you could go to your calculator and just put 6 pick 3 in your calculator, and you'll get 120 ways. All right, good. Let's take a look at another example here. However, if 3 swimmers are chosen to form an advanced team, then how many different teams are possible? All right, so how many different teams are possible? So in this case, among the 6 swimmers, 3 will be chosen and 3 will not. And that makes sense. We're just picking 3 swimmers to form an advanced team. So 3 will be picked and 3 will not. Another way to approach the question is, how many ways can 3 Ys, so I guess Y stands for yes, 3 Ys, and 3 Nos be arranged? Okay, so let's just check out what's happening here. Okay, so in this case right here, if I look at this first scenario here, I have 3 Ys and 3 Nos, and in this case, let's say the first Y is Y1, and the second Y is Y2, and the third Y is Y3. Now, if I have this rearranged, for example, as Y1, Y3, and Y2, in that case, it doesn't really matter if I have Y1, Y3, and Y2, because these 3 swimmers will be picked no matter what, so the order actually does not matter. Now in the previous case, first, second, and third, like when you're having gold, silver, or bronze, then it matters. But over here we know that 3 people will be going no matter what, so the order, like the Y3 could come first, Y1 could come second, and Y2 can come third. It doesn't matter. The order doesn't matter because all 3 of those Ys will be going on to the next round. So in this case, we have 6 swimmers still, and we just need to, well, basically for this problem, we can just treat it like the question from the last lesson, where we're just dividing by the repeats. So I have total number of 6 letters, and 3 of them are Ys and 3 of them are Nos, so I can use this little formula from the previous lesson and I'll get an answer of 20 ways. Alright, so now let's move on. So what is a combination? Combinations, they refer to the number of ways a group of objects can be arranged such that the order is not important. All right, so the order is not important. Now let's take a look at an example where the order is important first. Suppose we have 5 people, A, B, C, D, E, and they were in a game. How many different ways can 3 people be chosen for first, second, and third place? Well, since we have the gold, silver, bronze situation, the order does matter, so this will be a permutation. So this will simply be 5 pick 3, and in order to calculate this, since we have a 3 there, that means we have 3 spots, 1, 2, 3, and since 5 is our N, then we start from 5, then we decrease to 4, and then we decrease to 3. So there are my 3 spots to represent my R value. 5, 4, 3, the 5 represents the starting 5, and this would be 60 ways. Alright. So now suppose 3 people would be chosen to advance to the next round. How many groups of 3 can be created? Alright, so very similar to the previous problem, but we're going to try to analyze it a little bit more. let's take a look here. If we list out the permutations, some of them will be the same combination because they have the same letters. Okay, so let's take a look. I have ABC, ACB, BAC, BCA, and so on. So basically, from the group of 5 people, A, B, C, D, E, I'm just gonna get 3 of these people and arrange them. So here's my A, B, C, and then I might take the C guy out and put the D guy in. So this is another way where you can pick 3 people from the group of 5. And if we keep on going, if I list out all of the different situations here, so if I have 5 people here, and if I'm only using 3 of them, these are all the different kind of permutations that I can have. In fact, this answer right here, 60 ways, this answer comes from this scenario right here. So ABC is 1, ACB is 2, BAC is 3. So if you count all these individual groups of 3, you'll get 60. So this 60 is represented by this diagram right here. All right, so now let's talk about combinations here. Now, in a permutation, the order matters. For example, A, B, C, this is gold, silver, bronze. And over here, this would be gold, silver, bronze again. But in this case, the C guy won the silver. So the order is very important for a permutation. Now, for a combination is a situation where the order is not important. So let me kind of give you an example of a situation where the order is not important when I'm looking at this group right here. Let's say your teacher, Mr. Yoon, let's say Mr. Yoon gets very angry with 3 of his students. Let's say Alice, Brian, and Chris. They're causing trouble. They didn't do their homework. So Mr. Yoon will say, Alice, Brian, Chris, please go to the office. Now, if I say something like, Chris, Brian, Alice go to the office, is that really different than Mr. Yoon saying Alice, Brian, Chris go to the office? Not really, like those 3 people are still going to the office, right? So Alice, Brian, Chris are going to the office. It doesn't matter if I say Brian, Alice, Chris go to the office. I mean, that's the same thing as A, B, C going to the office. So in that case, the order does not matter because those 3 people are still going to the office, and if I just say their names in a different order, those 3 people are still going to the office. So that's a situation where the order is not important, and we call that a combination. So if I go back to this original question, suppose 3 people would be chosen to advance into the next round. How many groups of 3 can be created? Well, Alice, Brian, and Chris, they're going to go to the next round. So if you look at this whole column right here, this whole column has different, permutations of Chris, Brian, and Alice. So if you look at this whole column right here, this would only count for as 1 total group. Okay? So from this whole group would just count as 1 combination, because Alan, Brian, Chris is the same thing as Chris, Alice, and Brian going to the office. Sorry, I may have mixed up Alan and Alice a few times, but Alan, Brian, Chris, and Chris, Alan, Brian. Okay, so it doesn't matter how I say it, those 3 people are still going to the office, so this whole group represents just 1 combination. Now, if you apply that same theory over here, then Alan, Brian, and David, I mean, this whole group, these 3 people would go to the office together, and it doesn't matter if I say David, Brian, Alan. I mean, it's the same thing. So this whole column would also contribute to 1 combination. And we use that theory for this group, 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 and this group. So if we eliminate all the repeats, then we just have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer to this question would just be 10 combinations. Okay? And once again, for a combination, the order is not important. All right, now there is a formula for combinations. So when there are n number of objects with r number of objects to be chosen, the number of combinations will be n choose r. So sometimes we'll see it like this, or a lot of times in the textbooks you will see n choose r. and that's going to be n factorial divided by r factorial times n minus r factorial. So r is the number of objects chosen, and n minus r, which is this guy right here, that will represent the number of objects not chosen. All right, so there's my formula right there. Now another way that you could write this formula is this represents a permutation as well. So the combination formula is also a permutation divided by r. So if I have n choose r, this n factorial divided by n minus r, close brackets factorial, this part right here of the equation, that is actually a permutation. So I can write, so once again, this part right here is a permutation. So n pick r is n factorial divided by n minus r factorial. So this part right here matches up with this part right there, and I can substitute this for n pick r. All right, so there it is, n pick r divided by r factorial, and this is another way that I could write my combination formula as a permutation divided by r factorial, where r is the number of objects chosen. Let's take a look here. 5 choose 3. How can I compute this? Well, this is the same thing as 5 pick 3 divided by 3 factorial using this notation right here. And this 3 right here, this r value 3, means I have 3 spaces. So there are my 3 spaces. And since I have a 5 here, I will start with 5, then go 4, then go 3. And this 3 factorial would be 3 times 2 times 1 on the bottom. So 5 times 4 times 3. And then this 3 factorial is 3 times 2 times 1. And you get some nice factoring going on there. And you'll get 10 as a final answer. So this right here, 5 choose 3, and we get the answer of 10. This was the answer to the previous problem that we just did, where I did the example with Alan, Brian, and Chris. So 5 choose 3 will give you 10. All right, let's move on. All right, evaluate the following expressions, 6 choose 3 and 8 choose 2. All right, so let's do this really quickly here. There are 2 ways to do this question, meaning that you can use one formula or the other formula. So 6 choose 3 is going to be 6 factorial divided by 3 factorial times 6 minus 3 factorial. 6 minus 3 will give you this red 3. And then this expression right here, you can put in your calculator, or you can expand a few things, and you'll get 6 times 5 times 4 divided by 6. This red 3 represents that 6, and the 6 factorial on the top, if you go like 6 times 5 times 4 times 3 factorial, the 3 factorial here will factor out with this bottom 3 factorial, and you end up with this expression right here. The 6's and the 6's will factor out, and you just get 20. Another way you could do this problem is you could use 6 choose 3, and you could write this as 6 pick 3 divided by r. So this would be 6 times 5 times 4 divided by 3 times 2 times 1, and that will give you an answer of 20 as well. So this situation right here, I'm just using the second formula where I have my permutation divided by r. All right, let's go to 8 choose 2 now. 8 choose 2 using the formula 8 factorial divided by 2 factorial times 8 minus 2 factorial. That's the same thing as 8 factorial divided by 2 factorial times 6 factorial. And once again, you just apply some algebra here, and you'll get an answer of 28. And I will not do the second part because I think the second part is not too bad, so we'll just stick with this first part here. All right, so let's move on. All right, let's get on to a few more challenging questions. Practice, solve for n. So I have n choose 3 equals to 56. How can I solve that? All right, well, let's take a look here. If I apply the formula for n choose 3, I would get n factorial divided by 3 factorial times n minus 3 factorial. And then what I can do next is I can take my numerator here and I can expand that. And eventually, once I expand this, I probably want to factor that out with the denominator. So what that means is I expand the numerator here, n times n minus 1 times n minus 2 times n minus 3 factorial. I stop there, and I'll notice that this n minus 3 factorial on the denominator will factor out with the n minus 3 factorial on the numerator. And if I do that, I get this. And 3 factorial is simply going to be 6. So now you need to solve this mathematical expression right here. Now there's two methods to go from here. You could cross multiply or use factors of 56. I will try to use the factors of 56 here, because I know that these numbers here, n, n minus 1, n minus 2, they need to be consecutive numbers. So since, if you look at this 56 here, I know that 8 times 7 equals to 56. So let's just assume that the 8 here, sorry, this n value will be 8. Let's just assume n is 8. So 8 times 8, if I have an 8 here, then this expression will be 7. 8 minus 1 is 7. And then this expression here, 8 minus 2, will be 6. So something nice will happen. The 6 here and the 6 there, they'll factor out. And both sides of the equation are equal now. 8 times 7 equals to 56. So my guess of n equals to 8 is indeed right. So n will equal to 8. All right, let's move on to example number 2. 7 choose r equals to 35. So how can we solve this? Now there are two answers here. R represents the number of spaces. Okay, so right now, r, since we don't know what r is, I don't know the exact numerical value of the spaces that we'll have, but anyways, r represents the number of spaces. So if I have, for example, 7 choose 1, that would mean I have one space, and the numerator would be the 7, and the 1 will be in the denominator. And then 7 divided by 1 is equal to 7. So slowly what we're going to do is we're going to start from 7 choose 1, and we're going to keep on increasing the value of r until we get to 35. So after 7 choose 1, the next r value would be 2, so I have 7 choose 2 next. 7 choose 2 is simply going to be, well, this 2 means I have two spaces, so 1 and 2. So it would be 7 times 6, and this 2 would just be down here, because I have a 1 and a 2. All right, so after that, after 7 choose 2, the next number would, well, actually 7 times 6 divided by 2 is now going to be not 7, but it's going to be 21. So notice that we're slowly getting up to the 35. So after 7 choose 2, I have 7 choose 3. So I keep on increasing the value of r from 1 all the way up to 3 now. So there's a 3 here, so I need 3 spaces, like 1, 2, and this is my third space. And the numerator here will be 5. And then this 3 would just go down here. And so 7 times 6 times 5 divided by 2 times 3, that's going to give me a value of 35. So now I know that 35 here and the 35 there, they match. So the r value here would have to be 3. Now there is another answer here. If I do 7 choose 4 now, that would mean this would mean that I have another space here. So this 4 means I need 4 spaces, 1, 2, 3, 4. And since this number will probably be 4, 7 times 6 times 5, this is 4. And then this 4 would just go below here. And you'll notice that the 4 here and the 4 here, they will factor out, and you still get 35. So my two answers are 3 and 4. Moving on. All right, let's get into a few word problems here. A group of 10 students has 4 boys and 6 girls. So from the 10 students, I guess 40% of them are boys and 60% of them are girls. If 4 people are chosen to form a team, how many different teams can be created if there must be 2 boys? So the question says, if 4 people are chosen to form a team, so just from that sentence right there, the order does not matter. All right, just 4 people are chosen to form a team, so this is a combination. All right, so we can use, we're dealing with 2 different groups, boys and girls, and we can use the bucket method to separate the 2 groups. So what is the bucket method? Well, here's my bucket here, and I have 4 boys. The problem says I have 4 boys, and there must be 2 boys. Okay, so no matter what, I must have 2 boys. So if I have 4 boys, then here are my 6 girls. And from my 4 boys, I will choose 2 of them because I have 2 boys. All right, so if 4 people are chosen, okay, so we need 4 people and 2 of them are already picked for boys, so that means how many girls can I pick? Well, since I've used 2 boys, then I must have 2 girls. 2 plus 2 would give me 4 team members. All right, so this is going to be 4 choose 2 times 6 choose 2. Using the fundamental counting principle here, I'm going to take all the combinations here and combine them with all the combinations there, and that will give me a total of 90 teams. Okay, so this is just using the combination formula, and I get 90 teams. You could do it the other way as well. 4 times 3 times 2. Sorry, you could use the other way here, and you will still get 90 teams. I'm just going to ignore this part right now. I'm just going to simply stick to the formula here, 4r n minus r factorials, and I get 90 teams. All right, let's move on to the next problem here. If there are 7 boys and 10 girls, if there are 7 boys and 10 girls, okay, so we have 17 people total, and 6 people are chosen to form a team. How many different teams can be created if there must be 2 girls? Okay, we need to have 2 girls. All right, so let's make a bin again. We have 7 boys and we have 10 girls. Okay, so let's take a look here. I'm gonna choose 4 boys here, and the reason is because I must have 2 girls. So from my 10 girls here, I must choose 2 of them because that's what the problem states. If I use 2 girls, then that means I have 4 spots remaining, which will go to the boys. So 4 plus 2 will give me 6 people. And this is very similar to the previous problem, 7 choose 4 times 10 choose 2. Okay, and that will give me approximately 1,575 teams. All right, so these 2 problems here are very similar. We just kind of changed the numbers around, but it's the same idea. All right, let's move on now. 2 more problems here. If there are 4 boys and 6 girls, and 4 people are chosen to make a team, how many different combinations can be created if there must be at least 1 boy in the team? All right, so now the problem has changed a little bit. We must have at least 1 boy in the team. So we must consider all the different cases with 1 boy in the team, with at least 1 boy in the team. So I could have 1 boy and 3 girls. Remember, 1 plus 3 still gives you 4 people. I could have 2 boys. 2 boys is still at least 1 boy. So if I have 2 boys, then I must have 2 girls because 2 plus 2 will give me 4 people. Or I could have 3 boys. If you have 3 boys, that's still at least 1 boy in the team. So 3 boys and 1 girl. Or you could have all boys and no girls. All boys would still fall into this category, at least 1 boy on the team. All right, so we got to look at the combinations here and add them to the combinations here, and then add that to the combinations here, and to finally to the situation where we have 4 boys and 0 girls. All right, so 1 boy and 3 girls would be represented by 4 choose 1. Remember, we have 4 boys and we're only choosing 1 of them, so 4 choose 1. And we have 6 girls, so out of the 6 girls we're choosing 3 of them, so 6 choose 3. And then we add that to this situation here, 2 boys. So once again, we have 4 boys, but we're choosing 2 of them. And we have 6 girls, and we're choosing 2 of them. So 2 plus 2 will give you 4 people. Plus, this time we have 3 boys, so 4 choose 3 times 6 choose 1. Once again, 3 plus 1 gives you a total of 14 members. And finally, the last case is 4 boys. 4 choose 4 times 6 choose 0. All right, so in this case we have 0 girls, so 0 plus 4 still gives you a team of 4 people. And after this, you can go right to your calculator and get the numerical answer here. I'm just going to skip all these steps here and get the final answer here. The final answer here will be 195 teams. So if you're given 4 boys and 6 girls, where only 4 people are picked with at least 1 boy, you will have 195 teams. All right, let's go on to another similar problem here. A team is to be formed with 6 teachers. If there are 5 math teachers, 8 science teachers, and 3 English teachers, how many different teams can be formed if there must be at least 3 math teachers? And hopefully Mr. Yoon will be part of the 3 math teachers. So we need to have at least 3 math teachers. So and we could have a maximum of 6 teachers there. So we must consider all the different cases with at least 3 math teachers. So we could have 3 math teachers and 3 other teachers. We could have 4 math teachers and 2 other teachers. Or we could have 5 math teachers and 1 other teacher. But unfortunately, we cannot have 6 math teachers and 0 other teachers because we only have 5 total math teachers. Okay, so let's go back to the bin method if we can. So how many math teachers do we have? Well, we have 5 math teachers and we have 11 other teachers. How did I get this 11? Well, 8 science teachers plus 3 English teachers. That will give me a total of 11 other teachers. So from this case right here, from the 5 math teachers, I need 3 of them. And from here, I need 3 others. So 11, choose 3. Add it on to 4 math. Now I need to add that to the 4 math teachers and 2 other teachers. So originally I have 5 math teachers, but I only need 4 of them. And from my 11 other teachers, I only need 2 of them. So that's gonna be 11, choose 2. So this will be 5, choose 4, and this will be 11, choose 2. Over here, 5 math teachers. So out of the 5 math teachers, I want all 5 math teachers, and from the 11 other teachers, I want 1 of them. So 5 plus 1 still gives me a team of 6 teachers. So 5, choose 5 times 11, choose 1, and you simply add all those together, and you'll get a final answer of 1,936 different teams. All right, good. Let's look at a few card problems now. In a deck of cards, there are 52 cards with 13 spades, hearts, clubs, and diamonds. Find the number of combinations for each hand. Okay, so in a deck, there are 52 cards. So for all those students who've never played a game of cards before, poker or goldfish, here are all my cards here. So I have a total of 52 cards. It says right here I have 13 spades, 13 hearts, 13 clubs, and 13 diamonds. So if I look at my hearts, for example, my hearts are right here, and I would have 13 of those. For my diamonds, I would also have 13. And for my clubs, I would have 13 here, and my spades, I would also have 13 as well. Okay. And generally, there are 3 royal cards: Jack, Queen, King. So every single suite has 3 royal cards. So Jack, Queen, King. All right, so let's move my deck of cards over here, and let's look at the problems now. How many 5-card hands are possible? All right, so out of the deck of cards right here, if there's 52 of them, out of the 52 cards, how many 5-card hands can I have? Well, that's simply going to be 52, choose 5, and that's going to be 2,598,960 different hands. Okay, so how many 5-card hands with spades only? All right, well, here are my spades at the bottom here, and I have 13 of these spades, and I want to know how many 5-card hands can I have with spades only. So I have 13 total, and I want to choose 5 of them. So 13, choose 5 gives me 1,287 hands. And once again, the 13, choose 5, you can put that in your calculator, and you'll get this number right here, 1,287 hands. All right, question number C. How many 5-card hands with 3 hearts and 2 clubs can I have? All right, so how many 5-card hands with 3 hearts and 2 clubs? Well, let's look at the hearts here. Hearts would be over here. So I have 13 different hearts, and I want 3 of them. And for clubs, I probably want, there's 13 clubs as well, and I want 2 of those. So 13 hearts, choose 3, times 13, choose 2 clubs. And that's going to give me a total of 22,308 different hands. So once again, the 3 hearts, there's my 3, my 2 clubs, there are my 2 clubs, and the 13 and the 13 there, they just represent the different suites. Like this will be 13 suites over here, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Those are 13 cards in the hearts. All right, let's move on.